All right. Today we're going to be looking at Leetcode problem number 4, the median of two sorted arrays. So the problem is as follows. You were given two sorted arrays and you're expected to find the median of those two. So let's go over a couple examples, right? First example is your first array is 1 and 3, and your second array is 2, and you're expected to find the median, which is 2, because if you were to put these two arrays together, in order, they are 1, 2, and 3, right? So the median of that's 2. And a more complex example is example number 2 here, where the first array is 1 and 2, second array is 3 and 4. And basically, it's going to be the average between these two values. And that's because the length of the combined array is even in this case. So if the length of the array is even, the median of that is going to be the average of the two middle numbers. Okay, so how are we going to solve this? I'm thinking of two ways of solving this problem. So two potential ways of solving this. First potential way that I'm thinking is we can cheat, right? So we could cheat. And by this, I mean we can simply combine combine both arrays and sort them. Sort the final array. Based on this, we can simply get the median, okay, which should be fairly easy. The pros is simple to write. Cons here is that it's actually going to be fairly slow, right? Because the sort operation is going to take n log n, right? So that's not great. Of course, there's definitely better ways of doing that, but I'm just thinking of the fastest possible way of writing this problem, right? The other solution that I can think of is we can actually solve the problem. So solution 2 can be, actually solve the problem, meaning you iterate through both arrays and, basically just find the median, right? So iterate through both and actually find the median. I mean, needless to say that the first proposed solution, right, where it cheats, that would not fly in any kind of interview. But I can show you nonetheless, right, how that would look, and that should be fairly simple and fast to write. So why don't we go ahead and take a look at that. And for folks who just want to see, the actual solution to the problem, feel free to just skip ahead, right? So, as mentioned, we can simply just have a combined array. So maybe we call it ARR, and that's going to be, just the combined array nums 1 plus nums 2, right? That's sorted. Now, if len of array is, even, right? If it's even, and we have something there, then we can simply return ARR len ARR. We'll take the middle element, right? We'll add the middle element, right? So that will be len ARR divided by 2, right? Minus 1, right? Minus 1, because we want to get the element prior to the middle element, right? We get the element prior to the middle element. And then, of course, we'll take the average of the two, right? So that's just dividing by 2. If that's not the case, then we can simply do ARR of basically the middle element, right? Because that means so if we ever get to line 10, this means that the length of the array is not even. It's not even, right? So we have an actual middle element. Let's take a look. Yeah, so this is accepted. Maybe it's gonna TLE, maybe not. Okay, doesn't seem like a TLE, so it seems like the online judge is fairly lenient to allow us to do this solution, right? So, that's one way of potentially solving this problem. But this is not very interesting. So let's actually see how we would solve this problem. If you were in some kind of like interview setting or anything like that, right? So here what we need to do is we need to iterate through both of these arrays and basically so we need to maintain two pointers, right? And while maintaining these two pointers, we'll need to either increment the pointer for nums1 if that value is smaller than the value in nums2 or increment the other pointer, right? What I'm thinking that we could do here is we could probably define a helper function, maybe find index, which will take these two sorted arrays, right? So this will be nums1, nums2, and then it'll actually take, an index, maybe we could call it index, and it will basically return the value at that index as if these two arrays were sorted, right? So return the value at index as if both of the arrays are combined, right? So how does this look like? Well, as I previously mentioned, we'll need to maintain two pointers and we likely need to maintain some kind of results. So for this, we can simply initialize everything to 0. And our case here will simply be while we can iterate through this, right? Which is basically I plus j is smaller than or equal to my index, right? So while the sum of those two is smaller than or equal to the index, now there's two cases here that I think we need to consider. The first case is we ran through the nums1 array, and I is the pointer that I'm using for the nums1 array. J is for the nums2 array. So the first case is if I is equal to the len of nums1, right? Len of nums1, meaning there's nothing else that we can see in the nums1 array. In this case, it's fairly simple. All we need to do is increment the j array. And in fact, we can find exactly what value in nums2 we need to return, right? So this would simply be nums2 index minus I, right? Index minus I, right? Index minus I. Else if, right? Else if we ran out of the nums2 array, right? So that's j equals to len nums2. So if that's the case, we can simply do the exact same thing for the nums1 array, right? So nums1, this is going to be, oops, and yeah, so this is correct. So this would be index minus j, right? Index minus j, right? And that simply means that, in each of these cases, we ran out of one of the two arrays, right? So we just need to look at the whatever array is remaining. So if we don't hit any of these cases, then what we need to do is we need to compare the values between, values at nums1 and at nums2. And essentially what we need to do is we need to increment the pointers accordingly. How do we do that? So if nums1 at I, if nums1 at I, we'll call it smaller than or equal to nums2, because it doesn't matter if you include the equal here or not, but we'll just do so for posterity. And so basically, if nums1 at I is smaller than nums2 at j, so if the elements that we're looking at within nums1 is smaller, well, it's simply we need to increment the pointer at I, right? So I plus equal to 1. In this case, what I'll keep track of as well is the result. I'll keep track of the result. And the reason for that is once I get out of this loop, if I don't keep track of the result, I'll need to do the exact same comparison. So I just want to save some time writing that by just keeping track of the result here. That way I don't need to redo this afterwards, right? Because once I'm out of this while loop, I'm not going to know, should I be looking at I or should I be looking at j, right? So I'll just keep track of that here. Or we could just do the same thing on the other array, right? So this would be results nums2 at j, and of course we'll need to increment j, right? Increment j. Note that by doing this, we need to iterate up until we're equal to the index, That's because the index will reach, each of these pointers will reach their desired value prior to the result. So the result is essentially a lagging indicator, right? Whereas the pointers are leading, right? Now, if we exit out of this successfully, we can simply return the result, right? Okay, so now that we've defined this find index, how do we actually solve the problem? Well, I think it should be fairly trivial, right? In once we have such a function defined. And the first thing is, well, let's define what is the length of this combined array that we'll be looking at, right? And that's very simply just the sum of the two lengths, right? So that's nums1 plus length of nums2, right? If this length is odd, we'll be doing so exactly as we had in our first solution, right? If the length is odd, we'll be doing one kind of operation. If the length is even, we'll be doing some other kind of operation, right? So how would that look like? So if length is divided by 2 is equal to 0, right? So meaning if it's even, and the length is non-zero, right? Then what we need to do is we need to return the average between the two numbers. Else return the middle value. So let's code returning the middle value. I think that's easier. That should be very simple, right? Return self dot find index nums1 nums2. My index is simply going to be n divided by 2 as an integer. And here, very similar to, right? We'll simply just find the index for both my middle value and the value right before that, just like we did in the first solution. And then I'm just going to divide whatever that result is by 2, right? So that will be find index nums1 nums2 and divided by 2 plus I'll put this in a new line, self dot find index nums1 nums2 and divided by 2 minus 1, right? And then what I'll do is I'll just divide all of that. Divide all of that by 2. Okay, let's run. Let's see if that solves the problem. Runtime error. Okay, so find index positional. Takes 3 position out of 4 were given. Okay, looks like I have a bug here. Takes 3 positional arguments, but 4 were given. Oh yes, of course, because I defined this incorrectly. I need to pass self, right? I need to pass self in this find index. Awesome. So first 2 cases look good. Let's submit. Let's see if it passes. Awesome. So this is the solution, that we first did here on the sorted array. Looks like we passed, and on this new solution, looks like we passed as well. Awesome, folks. Thank you for watching. I hope you enjoyed. Don't forget to like and subscribe.